we moved on to merge and diverge segments of freeways. Now keep one thing in mind, the adjustment factors, they remain the same for all types of segments, so we will not discuss them again, but the same adjustment factors can be applied to merge and diverge segments as well. So this is the methodology. I described to you the segments, and the main thing where we stopped was to get the proportion of traffic in the first two lanes. So we had the concept of influence zone for the merge and diverge segment. For the merge, it is after the ramp, 1500 feet, the first two lanes. For the diverge, it is before the ramp, because it is exit, so before the ramp, the first two lanes, 1500 feet. Okay, so from the total of the freeway, how much volume we have on in the first two lanes. That was the thing which we are trying to find out using this equation. Okay, so we need the percentage of flow in the first two lanes for the merge segment and for the diverge segment, one of these two. And I showed you these tables. Okay, we have some conditions and you have to apply them according to the conditions. Now we'll start with an example here. Okay, so we have two examples here, and for each one of them you can see the flow on the freeway, the flow on the ramps. Okay, our ramp is this one, the one in the middle, in both cases. Okay, so this one is an entry ramp, so we call it a merge segment. So we have a merge segment here, and this one is an exit ramp, so this is a diverge segment here. Okay, and you have 1000 feet here to 100 here, and you have 800 feet here and 1500 feet here, the distances between the ramps. And what else? Yes, the length of the acceleration lane, okay, that is 400 feet. Okay, length of the acceleration lane or the deceleration lane, and so we have the same length in both cases. Again, to remind you, acceleration lane is when you enter the highway, you have an extra lane in which you can enter, and then you can merge later on onto the main highway. So that is an acceleration lane. Deceleration lane is the exit lane for this ramp. So we have an extra lane here where you can go and then exit from the ramp. So that is the deceleration lane. Okay, so we have the first one, this one. Okay, and now they have already done this step. This step is already done for all the flows. So all flows are in passenger cars per hour. All of them are flow rates. We start with the merge segment. So we have to do VF into PFM. Okay, so we are trying to find out V12 in both cases. So first one is a merge section. We are doing this. I want PFM. VF is given. Okay. So this is my VF, 2000. I have to find out PFM here. Okay, so I'm here. Okay. Now in this case, did they give the number of lanes? Yes. Both of them are 6-lane freeways. Okay, both of them are 6-lane freeways. So I'm looking at this. Okay, so I have three possibilities here. I can use equation 5.28, 29 or 30. The selection will come from here. Okay, now the case which I have a ramp upstream and a ramp downstream, both. Okay, so if I look at the first three cases, they don't have any ramp upstream, so I cannot select from here. If I look at these two cases, I have no ramp downstream, so I cannot select from this one as well. So it has to be one of these last four cases. Okay, so if I go back to the question, the upstream means before. The before ramp is on, going in, and the downstream means after, so that is off, going out. So on and off. So on and on, not this one, and on and off. So I'm looking at this one now. Okay, so this is my case. In this case, I have uh, uh, these two options, 5.28, 5.30, depending upon the distance and the equivalent length. Okay, the distance between the ramps and the equivalent length. Okay, so the distances are given. I have to find out the equivalent length. Okay, so equivalent length for upper stream off ramp and downstream off ramp. Now which one do I have? I have the downstream off ramp. Okay, upstream is not off ramp. Okay, so I will check with downstream off ramp. So VD means the flow on the ramp itself, and LA is the length of acceleration lane, which is 4,000 feet. Oh, sorry, 400 feet. So LA is 400 feet. VD, the flow on the downstream ramp, this one, which is 400. Okay, so VD is 400 and LA is also 400. So how much is the equivalent length here? Tell me. Yes, how much is LEQ, the second one? Okay, so if I compare it with D, the D is the distance between the two ramps. I'm doing it for the off ramp, this one. So distance is 1000 feet. Okay, so you found 2000 feet here and the distance is 1000 feet. So D is less than LEQ. Where is it? Oh, sorry. Okay, so distance is less than LEQ. Okay, so I will use equation 5.30. So this is equation 5.30. Okay, L down is means the distance for the downstream ramp, and VD is VD is 400 and L down is the distance 1000 feet. Okay, this distance and this flow. So how much is that? 400 and 1000. How much is PFM? So my D is less than LEQ. I'll use equation 5.3. So how much is my PFM here? Yes, how much is PFM? Okay, So 58% of the traffic will be in the first two lanes. So the flow in the first two lanes will be the we are using the merge section, so this one. So I need the flow on the fluid on the freeway, which is 2000 here. Okay, so this will give you the flow in the first two lanes. How much is that? Okay, so this is how this is done. Then moving on to the second example, which is for the diverge segment. You have the off ramp here. So again, the upstream ramp is on and the downstream ramp is off. Okay, and you have everything here. Okay, so if now I will look into this table, 6-lane freeway, I have three possibilities, these three equations. I have to use one of them. Again, the first three cases, no upstream ramp. The next two cases, no downstream ramp. So I'm looking at the last four cases. The last four cases we have on and off. So I'm looking at this one now. Okay, upstream on, downstream off. So I'm looking at this one. So they are saying you can use any of these three equations. Okay, you can use any of these three equations. Usually it is advisable to take the higher value then. Okay, you take the higher value after you calculate these three values from here. Okay, so VF in all the cases is 2200. So VF is 2200. Okay, I need VR, which is a flow on my ramp. So VR is 1000. Okay, and I need the flow on the upstream ramp and the distance to the upstream ramp, flow on the downstream ramp, distance to downstream ramp. Okay, all of them are given here. Upstream ramp flow 500, distance 800 feet. For the downstream, sorry, should be up. It is 800. And the distance is 1500. Okay, so you have everything now. Give me the three values. We'll take the higher one in the end. From all three equations, we will select the higher one. These three. See here, they are saying you can use any of these three equations. So we'll calculate from all these three equations. Then you select the higher one. Okay, the other two. Okay, and the last one. Okay, so now you can see we have three options here, 0.641, 1, you cannot do more than 1, by the way. Okay, so this is 1.0087 is, we'll take it 1. Okay, because we are talking about proportion here. Proportion cannot be more than 1, right? And you have 0.636. Okay, so the highest one is 1. So 1 means that we are assuming that the entire flow will be in the first two lanes. Okay, it's a very extreme situation, but this is what it is. Okay, but the point here to be noted is, if you have different options, if you have one in this sequence, okay, then you should take the highest one, and the highest one cannot be more than 1. Okay, so in this case you can take 1, so you are almost in this case, the 4-lane case. Okay, does anyone have any questions? Is it clear? Okay, and again, why we are taking the highest one? Because that is that will give you the maximum flow. Okay, so you are taking the worst case. Okay, the highest one gives you the worst case. Okay, so after you have found these factors, you found the flow in the first two lanes, there are few checks you have to apply before you move on to the next step. Okay, there are this is one check, and then we have some other checks here as well. Okay, so there are 3 or 4 checks before proceeding to the next step. The first check is on the value itself. So you check the values, and if the checks are not satisfied, you adjust the value. Okay, so this check is for adjusting the value. So they are saying the flow you have found in the first two lanes. Now remember, we are talking about 6-lane and 4-lane freeways here. Sorry, 6-lane and 8-lane freeways here. If you if you have 4-lane freeway, these checks do not apply. These particular checks do not apply. The next ones will apply to all of them, but this particular one, only applies if you have 6-lane or 8-lane freeway. Okay, so according to these two checks, the first one says that the flow per lane, uh, yes, the per lane flow should be less than 2700. Okay, the average flow in the outer lanes. Okay, yes, so outer lanes are what is remaining. Outer lane is what is remaining. So after you have found V12, okay, so in the first case, that is okay, so my flow was this much in V12, and the complete flow, the full flow was 2000. So out of 2000, I have 1176 in the first two lanes. So the remaining 800 something in the outer lane. Okay, and since I have only one outer lane, so that is 800 something per lane. Okay, so if I apply the check on that one, it will be satisfied. But if it is not satisfied, you will recalculate the V12 using one of these equations. So if you have 6 lane freeway and the check is not satisfied, you will recalculate V12 from this equation. If you have 8 lane freeway, check is not satisfied, you will recalculate V12 using this equation. Okay, so the check is the outer lane volume per lane should not be more than 2700 per lane. Okay, if it is, then V12 must be recalculated using one of these equations. The second check is again on the per lane flow in the outer lane, but it is between the ratio. So the per lane outer lane flow should be less than or equal to 1.5 times the per lane of V12. Okay, so if you take the ratio, per lane ratio of outer lane upon inner lane, it should be 1.5 or less. Okay, uh, 1.5 times the so in this case, okay, I have 1176 here. If I calculate it per lane, there are two outer lanes, right? Oh, sorry, there are two lanes, not outer lane. Outer lane is one. There are two lanes here, so 1176 divided by 2, it will give you how much? How much is 1176 divided by 2? Okay, so now they are saying the outer lane per lane. The outer lane, so if you subtract it from, if you subtract 1176 from 2000, how much you get? Okay, so now they are saying the this 824 should be 1.5 times 588 or less. Okay, so 1.5 into 588, how much is that? Yeah, so you have 882 here and your outer lane flow is 824, so it is less. The outer lane flow is less than 1.5 of the inner lane per lane. Okay, so we satisfy this check. But if you didn't satisfy this check, again you do the same thing. You will recalculate V12 using one of these equations. This one for 6 lane freeway and this one for 8 lane freeway. Okay, so you apply the check. You need outer lane per lane flow here, and you need outer lane and inner lane per lane flow for this one. Okay, in the first one you are checking it against 2700. In the second case you are checking it against 1.5 times of the inner lane for per lane. In any case, if the check is not satisfied, V12 must be recalculated. Here recalculated using one of these equations, here recalculated using one of these equations. Okay, so for example, if okay, so if your VF is 4000 and V12 is 3000. Okay, so let us apply the checks to this case. Okay, I not mentioned the number of lanes. Let's say we have 6 lanes. Okay, 6 lanes. So this is for a 6 lane freeway. Okay, so if I apply the first check, outer lane flow, freeway flow is 4000, V12 is 3000. How much is the flow in the outer lane? Tell me. Yes, what is the outer lane flow here? Tell me. VF means total flow. Out of total, V12 is 3000. So how much is remaining in the outer lane? Yes, anyone? Outer lane is what is remaining from V12. That will be outer lane. Okay, so outer lane, if I say V0, then it will be 4000 minus 3000. Yes. Okay, so my outer lane flow is 1000. Okay, since outer lane is only one, okay, so we have 1000 in the outer lane. If I apply the first check, the outer lane flow is less than 2700. It's only 1000. Okay, so this check is satisfied. Okay, so I don't need to recalculate. If I come to this one, okay, I have inner lane which is 1500. Okay, 3000 divided by 2. Inner lane per lane is 1500. The outer lane is 1000. Okay, so if I multiply 1500 by 1.5, I will get an answer which will be more than 1500, right? And my outer lane flow is already less than 1500. Okay, so this check is also satisfied. Okay, 1000 is obviously less than 1.5 into 1500. Clear or not? Okay, moving on. So these were the two checks on the values where you will recalculate the values. Now these are called capacity checks. The ones which we are doing now, these are called capacity checks. Capacity checks, if they are not satisfied, you can decide the level of service directly. Okay, these are three checks. The first one is the capacity of the ramp. Okay, the ramp which you have in your segment. Okay, not the upstream and downstream, the ramp in your own segment. Okay, so the capacity is given according to the free flow speed on the ramp. So you must know the free flow speed on the ramp. Okay, so this is the capacity, and you check if the flow on the ramp, the fluid on the ramp is more than these values, your level of service is F. Okay, so if this check is not satisfied, the level of service is F. You can stop here. Okay, the second one is capacity of the freeway itself. Okay, if the flow on the freeway is more than the capacity, the level of service is F, and you can stop there. Okay, so the capacity is given here. Okay, again as per the free flow speed. For capacity, we have seen equation for the freeway. So if your free flow speed is 66 or 67, you can calculate the capacity using the previous equation, this one. Okay, so there are equations. There is equation to calculate capacity of freeway. So you can put the free flow speed yourself and calculate it. Okay, if your free flow speed is not written in this table. So in any case, if the flow on the freeway is more than the capacity, remember it is per lane, so you have to convert it to per lane. Okay, so any per lane, V12 or outer lane, any per lane is more than the capacity, then the level of service is F, and you can stop the analysis there. Okay, so if it is more than the ramp capacity, level of service F. More than the freeway capacity, level of service F. Now this is for the check for V12, and usually at this after this check, if it is not satisfied, the level of service is not said to be F. Okay, we can continue with the analysis. So if your V12, for this is for the merge area and this is for the diverge area. Okay, for the merge area, the maximum V12 is 4600, and for the diverge area, the maximum for the diverge area, the maximum is 4400. If you exceed these values, we will put a note after the analysis that the actual speed could be, an actual density could be, uh, the actual speed could be lower than what you are calculating, and the actual density could be higher than what you are calculating. Okay, so this check is like a limit for the analysis. Okay, so for the first two checks, if you satisfy them or if you violate them, the level of surface is F, analysis stops. The last one, okay, so these are not two checks, because either you will have the merge section or the diverge section. You cannot have both in one segment. So if you have merge segment and you did not satisfy this check, we will continue with the analysis. We will not say level of surface is F. We will continue, but we will say that the actual speed and density could be different from what you are calculating. Okay, so the actual condition on the highway could be worse. This is the point here. But in any case, for the last one, the analysis will continue. Okay. Once you have done all the checks, then you can move on to calculate the density. Okay, the density for the merge section will use this equation, for the diverge section will use this equation. And based on density, you can find out the level of service. Okay, the same table which we have used, or similar table which we have used for basic freeway segment. The values are different, by the way. So it's not the same table as basic freeway. It is similar, but not the same because the values are different. For basic freeway, this one is 45 and these values are also changed. In addition to finding out the level of service, we also need to find out the density and speed for each group of lanes separately. So we have two lanes which are in the influence area. The first two lanes are in the influence area. Okay, and then we have the outer lane as well. If you have 6 or 8 lane freeway, then you have the outer lanes as well. So we can calculate the speed for these set of lanes separately using these equations. For the merge, you will use the first set of equations. For the diverge, you will use the second set of equations. So what are we using here? Free flow speed, FFS. The speed adjustment factor, we have talked about it in the previous lecture, and I told you they will not change. Okay, so they are the same. And then you have ms here. Ms can be calculated from here. So you need V12, speed adjustment factor, free flow speed of the ramp, and the length of the acceleration lane. Okay, so all these factors we have already used, and this is exponential. For the speed in the outer lane, it depends upon how much volume you have in the outer lane. Okay, if less than 500, speed equals to free flow speed. If it is between 500 and 2300, speed equals to this. Okay, and this is the flow rate in the outer lane. VOA means flow rate in the outer lane. And then if you have more than 2300, speed will come from here. For the diverge section, this is the equation for the first two lanes. You need ds here, so this is the equation for ds. Vr means the flow rate on your ramp, on your own ramp. Then for the outer lanes, again you have to check these two conditions. If the flow in the outer lane is less than 1000, speed equals to this. As if it is more than 1000, speed equals to this thing. Okay, so you already have so yes, what they are saying here is that the outer lane should also be converted to per lane here. So VOA is per lane. It's not mentioned here because we can have one outer lane or two outer lanes. So if you have only one outer lane, if you have 6 lane freeway, 3 lanes in each direction, that means only one outer lane. So you don't need to do this. Okay, it's already per lane. But if you have 2 outer lanes, then you need to divide by number of lanes to get the per lane flow here. So here we need per lane flow rate in all cases. Okay, so these equations will give you average speed in each set of lanes, the V12, the 1, 2, the first 2 lanes and the outer lanes. If you want to calculate the density for each set of lanes, then we will use a simple equation of density. flow rate you already know, divide by the speed. You already know V12 and you already know V outer lane. So you divide by the speed you find from here for each set of lanes. So if I'm using V12 here, again you have to use per lane here. V12 should also be, for the density, should be per lane. So you will divide by the speed of the first two lanes. Okay, this SR or this SR, and so on and so forth. Uh, and for the outer lane again, you will use VOA here per lane, and then you divide by the S0, either from here or from here. Okay. Anybody has any questions? Okay. So yeah. So we have talked about here density of the whole segment, speed of different set of lanes, density of different set of lanes, and this is speed of the whole segment. So this gives you the speed of the whole segment. Okay. Same here. Speed of the whole segment for the merge and for the diverge. All parameters are what we have discussed earlier. So you can find out speed and density for the whole section, including all lanes. And for the level of service, we usually use the density of the whole segment. But if you want for further analysis, you want the speed of the whole section, these are the equations. If you want the speed and density for each set of lanes separately, you can use these equations over here. Okay, so I hope it's clear. Otherwise, we are doing some more analysis to make it clearer for you. We have a merge section here. The free flow speed of the ramp and the freeway is given. We have rolling terrain, percentage of trucks are given for both cases, peak hour factor is given. All the adjustment factors are equal to 1. Okay, and what else? Yeah, the 1000 feet is the acceleration lane. You can see we have 4 lanes on the freeway. So it's a 8 lane freeway. 4 lane in one direction, so it's a 8 lane freeway. Okay, so we will start when we start the calculations, we have to look for the free flow speed. Free flow speed are given for both freeways and the ramp. The free flow speed is given, so I can move forward. The next step is to convert the given volumes into flow rates. I have to convert the given volumes into flow rates. So I need to divide them by peak hour factor and the factor for heavy vehicle. The factor for heavy vehicle needs to be calculated. Okay, so the factor for heavy vehicle is this one. Okay, so if I'm doing it for the freeway, then it will be use a percentage for the freeway and the equivalency factor for the terrain of the freeway. The terrain is same for the freeway as well as the, so the percentage of trucks for the freeway is 5%, so 0.05. Terrain is rolling for the freeway as well as the ramp. I have a table to find out ET. I have number of tables, but for rolling terrain I have one table, this one. Okay, so rolling terrain ET is 3. Okay, so this is for the freeway, and for the ramp it will be 10% trucks on the ramp. So how much is the FHV for the freeway and the ramp? Tell me. Okay, this is for the freeway. How much for the ramp? Okay, then I will go on and calculate the flow rate for the freeway and the ramp. Okay, so flow rate on the freeway. Okay, the given is 5200 divided by 0.909 and the peak hour factor, which is 0.92. Okay, so this is for the freeway. For the ramp, it will be 900. The peak hour factor 0.89 and the factor, which is 0.83. Okay, so how much are these values? Okay, this is for the ramp, or this for the freeway. Okay, and for the ramp? Okay, so now we can move on to finding out the V12. Okay, we will use total values, okay, like rounded off values. So 6218 passenger cars per hour for the freeway, and for the ramp we will use 1214, the nearest one. Okay, I'm just doing simple rounding off here. Okay, so I will find out V12. I have a merge section, remember. Okay, so all the analysis are for the merge section. If I go here, okay, merge section, this one, PFM, I'll go here, merge section, 8 lanes, I can use this equation or this one. Okay, one of these two. Okay, and depends upon this table. Okay, did they give me any data for the on and the off ramp? This is a different example. We're talking about this one. No data about the on, like the upstream or downstream ramp, right? Okay, so I will assume the one, it's yeah. Okay, so this depend. Okay, so I don't need the honesty I don't need the upstream and downstream because the conditions are given here. Sorry for that. So Vf upon SFR will tell me which equation to use. I have these two options. Okay, Vf you calculated, SFR is given 40 miles per hour. Okay, so free flow speed on the ramp, right? Okay, so Vf is this one and SFR is 40. So how much is Vf upon SFR? How much is that? So Vf is for the freeway and SFR is the free flow speed for the ramp. Okay, so we are here. Okay, so we will use this equation. So I will just simply put VR here. Okay, my VR is 1214. Okay, so PFM equals 0.2178 minus So how much is that? Yes, how much is my PFM? Okay, so now I can calculate my V12. V12 is the VF, which is 6128 multiplied by the PFM, which is 0.066. So how much is that? Okay, so now I will apply the checks. Okay, I start applying the checks. So I need the outer lane flow rate here. Is this value correct? Did somebody else did it? Is this 0.066 correct? Or then if you can recheck it, because the rest of the analysis will depend upon it. Okay, so I will find out the V outer lane per lane. Okay, so I have 8 lanes now. So this V12 is in the first 2 lanes. My total was 6128. Out of that, 404 is in the inner lanes. Okay, I divide by 2 to get the per lane, because the outer lanes are 2. Total are 4, so the outer lanes are also 2. So how much is this per lane? Okay, so if I look at the first check, the per lane outer should be less than 2700, but it is more. Okay, so I need to recalculate the V12 using this equation. Okay, so V12 will be the total VF minus 5400. Okay, so my VF, oh sorry, my V12 will be, total was 6128 minus 5400. So how much is that now? So V12 is recalculated now. The one which I calculated earlier did not satisfy the check. Okay, so V12 is now 728. Now on this 728, because the first value is gone, 404 is not, did not satisfy the first check, so I don't need to continue with it. So I will move on to the second check with the new value now, 728. Okay, if so, again I need the outer lane volume. So V per lane, the total was 6128. The new V12 is 728. Divide by 2 for 2 outer lanes. So how much is the new outer lane volume now? Okay, and this value should be less than or equal to 1.5 times the 1.5 times 728. So is it less? Is it less than this value? 1.5 times 728 will not be more than say 2700, right? So not satisfied. Okay, if this check is not satisfied, we have to recalculate V12 again. So even the 728 did not satisfy the next check. So I will recalculate V12 using this value. Okay, so VF, the total VF remains the same, it doesn't change. We are just distributing the volume. So 6128 divided by 2.5. This will be my V12 now. The final V12 will be this one. Remember, we are doing it because the checks are not getting satisfied. Okay, so this is my new V12. Okay, so we don't need to go back. You go from one check to the next one and just continue. Okay, so this is my new V12 2451. Okay, so now we'll move on to the capacity checks. So the flow rate on the ramp should be less than its capacity. My ramp has a speed of 40. Now 40 will be here, not this one, okay, because this one doesn't have equal to sign. So 40 is here. So my flow rate on the ramp should be less than 2000. The flow rate on the ramp, you calculate earlier, flow rate, okay, not the volume which is given, the flow rate. The flow rate is 1214. Flow rate on the ramp is 1214 and the capacity is 2000. Okay, so ramp capacity check satisfied. Next one is freeway capacity check. Okay, my freeway has a speed of how much? 65. Okay, 65 is this one. Okay, any per lane volume should not be more than 2350. Okay, any per lane volume, per lane. Now the outer per lane, you calculated the inner per lane. The V12 is 2451. If I divide it by 2, I will get 1200 something. Okay, so less than 2350, no problem. I need to see how much will be the outer lane volume. Okay, so outer lane per lane. Okay, my total was, so before I perform this check, I need to find out the outer lane per lane with this 2451 here. Okay, so total was 6128 minus 2451 divided by 2. How much is that? Okay, so we are satisfying the check over here for outer lanes as well as inner lanes. So I can move forward. Okay, and yes, V12, we have merged area. V12 should be less than 4600. My V12, the new one, is this one, 24 blah blah. Okay, so this is less than 4600. We don't have any problems. We can say whatever we are calculating is good. Okay, so after all checks are performed, I will move on to calculating the density. So this is my density. Okay, so I need the flow rate for the ramp. I just look for the, so this is acceleration lane, LA is 1000. Okay, so the density of merge section 5.54. Since it is an equation, so I will not round off the numbers. Okay, equation, I will write the numbers as they are. 734 multiplied by VR, which was 1214. V12, the latest one, which is 2451 minus 0.00627 into the LA, which is 1000, the acceleration. Okay, how much is this? How much is the density? Yes, how much is this density? Okay, so if this is the density, then the level of service is C. Okay, so we found the level of service and density. Now we can do these other things as well. We have merge area. So for the merge influence area, first calculate MS here. Okay. Plus 10039 to e power VR12, which is 2451 divided by 1000 minus 0.002 acceleration length, free flow speed of the ramp 40, no adjustment factor, so just divide by 1000. Okay, how much is MS here? Yes, how much is MS? Okay, so we can move on, calculate the speed and the influence area. So free flow speed of the freeway itself minus this into 0.286. How much is that? Okay, so this is for this one, then this one. we have to know the we have to select the equation based on the VOA per lane. My VOA per lane was how much? 1838. Okay, so 1838 is here. So I'll use this equation. Okay, so S naught 65.0036 1838 minus 500. Okay, so how much is that? These values are in miles per hour. Okay, so now I can calculate the average speed of the section using this equation. Okay, so average speed of the section 2451 plus 1838 into 2 lanes. So 2451 divided by the speed in the ramp area, which is 46.41, plus the outer one, which is 1838 to speed in the outer area, which is 60.183. Okay, so how much is this? Okay, so this is the speed of the whole section now. Do you have any questions? Does anyone have any questions? Okay. So we have another question over here. This is for the Diverge section, I believe. It's a 6-lane freeway. Off ramp means it's a diverge section. Okay. Ideal geometry means no adjustment factors. Free flow speed is given. Terrain is level. Obviously, the terrain will be same for the freeway and the ramp. Okay. Free flow speed for the ramp is given. Deceleration lane is length is given. The freeway has 4,850 flow, and the off ramp will carry 800 out of that. So from 4,850, 800 will go off the ramp. Okay, so the actual one will be 4,050 for the freeway. Okay, and upstream there's an upstream ramp half a mile. Okay, so half mile you have to convert it to feet to see the PFT factor. Okay, and that has a flow of 900. All traffic has 9% trucks, level terrain, peak hour factor 0.93. So for all of them, okay, for all of them, The peak hour factor is 0.93, and you have to calculate the heavy vehicle adjustment factor using 9% trucks and level terrain. Okay, so I will just write down the steps here. The first thing you will calculate is FHV. Okay, for the you need to calculate it for the freeway and for both the ramps. Okay, and then you will calculate flow for the same. Okay, for the freeway as well as for the ramps. Okay, once you have done that, you will find out PFD factor. For that we have tables. After PFD you will find out V12, then you will apply the checks, all the checks which we did today, and then you will move on to, once the checks are applied and you don't have level of service F, because in some of the checks the level of service can be directly F. If you don't have that, then you will calculate the density. Okay, density will give you level of service, and then you will calculate SR and S0 and S like we did in the last step. Okay, so I leave it up to you if you can bring it in the next lecture. Okay, or let me do something. Okay, we have a lecture on Thursday, so I'll do it on Thursday. Okay, people who can attend should attend, and the people who are from 432, you will have the recording, inshallah. I'll record it. Okay, so I will solve this example in the Thursday lecture, inshallah. Okay, so anybody has any questions?